Welcome back to page 3 of Algebra Review in Algebra 2. Let's start with number 12 here. This is page 3. This page just has 2 problems on it. You just need to sketch a graph of each one of these. The first one, there's no exponents at all. We know it's linear. It's going to make a line. This is standard form. We do much better when we have it in slope-intercept form. So I'm going to rewrite the equation over here and solve it for y. Excuse me, I almost forgot my equal sign here. So 3x minus 2y equals negative 10. So I want to subtract 3x from both sides. I want to move that over. When I do that, I get negative 2y equals. Now this is a personal preference. Since it's mx plus b, I always tend to put my x's first. So I'm going to actually write the negative 3x next, and then the negative 10. It is not wrong at all if you have those reversed. Then I'm going to divide everybody by a negative 2. So then I'll have y equals, this is my slope, which I am totally fine with that as a fraction, but 2 negatives make a positive. This is my y-intercept, so a negative 10 divided by a negative 2 is plus 5. So now I'm ready to graph. I'm going to find 5 on the y-axis. That's my y-intercept. My slope is 3/2. I could go up 3 and estimate about where 2 is over, or I can do the reverse and go down 3, back 2, down 3, back 2 to draw my line, which has a positive slope. So there's the equation in slope-intercept form, and that's what it would look like on your graph. The next one is graphing an absolute value, which I'm not quite sure if you covered all of this in Algebra 1. What I advise that you do when you have to graph something and you're not sure what it looks like is to go to your calculator, press y equals, and type the equation in. The equation is 2, and then it's an absolute value, which you can find under Math. Go over to Num. Abs is the first one. X minus 1. This button right here next to alpha is x minus 1. Get out of the bars, and then there's a minus 2. If I haven't graphed for a while, I'm going to hit zoom and choose number 6 for standard, just to make sure my window's good. What you'll find is many times when you graph absolute values, well, if that's all there is in the equation, it will make some sort of V. So here is our V, and I like to graph it because then I get an idea of what x values might be good to put in. For example, the vertex, the point down here, is when x is 1. So if I'm going to make a table of values, I'm going to make sure I put 1 in, because that's where the vertex was. And then I'm going to put numbers before 1, which would be 0 and negative 1, and maybe some numbers after 1. Which would be 2 and 3. I substitute those into the equation. You can do it in your head. For example, you could go negative 1 minus 1 is negative 2. Absolute value of negative 2 is 2. 2 times 2 is 4. 4 minus 2 is 2. Or you may go to your calculator, go to a regular, plain, clear screen, and type it in and substitute in for x, the x value that you have in your table. So 2, then Math, Num, Abs. There's an x. I'm going to put the 0 in. Minus 1, and then outside the bars is a minus 2, and I get 0. What's really nice about your graphing calculators is you can hit the up arrow. And now I don't want to be substituting in a 0. I want to substitute in a 1. So I'm going to go where the 0 was, change it to a 1, and I get negative 2. Then I'm going to go up and change that first 1 where the x is and change it to a 2. And you know, what's nice about absolute values is you start to know if you did things right, if you get some repeats here. I'm going to change the 2 with that 1 inside the bars to a 3. Then I'm going to graph them. Negative 1, 2. 0, 0, 1, negative 2, 2, 0, and 3, 2. Now, I could have put a ton more. I could put in an infinite amount of x values. I think that's enough to be able to figure out my V here. Obviously it continues, runs off. Now I wish our calculator when we graphed it put arrows on it, but it does not. If it runs off the screen, we know it goes on forever. I'd also like to do with this one, I'd like you to list the domain and range. Hopefully you remember that domain is how far left or right the graph goes. It's what x's you can plug into the equation. Ours actually goes forever right, forever left. We can plug any x value in we want. Your teacher might have said last year a big fancy R for all real numbers. They may have written what's called inequality notation, which means x can be anything between negative infinity, infinity. This year, I'd like to start pushing interval notation. Interval notation means you write whatever the smallest thing, in this case it can almost be, because you can't really plot negative infinity, and the biggest it can almost be is positive infinity. I realize that that looks like a point, but it is actually interval notation. The domain has all x that are an element of that set. I am totally fine with you just writing this, parentheses, negative infinity, comma, infinity. Now the range, remember, is your y values. It's how far up or down it is. You'll notice this graph goes forever up. It has a low point. The lowest it is -2. Now last year in Algebra 1, they probably had you do something like all the y's are greater than or equal to -2. It actually can be -2. There is a solid dot at -2. I personally prefer inequality notation. The smallest or the lowest it is -2. You'll notice I'm putting a bracket because there's actually a solid dot at -2, and the highest it can be is infinity. The highest it goes on forever up, and again, we use parentheses for that because we can't really graph infinity. It's not an actual point. So this and this mean exactly the same thing. I'd like to start pushing for this right here. So that's 12 and 13. That is page 3. I'm actually going to try to continue on to page 4 here, see how many I can get done. Here's page 4. These are systems, meaning there's 2 equations and there's an x and a y in each one. If they say solve by graphing and they're already in slope-intercept form, I would just graph them right there and see where they cross. For example, the y-intercept is 4, solid dot at 4. Slope is 1/3, up 1 over 3, or you can say down 1, back 3, and draw your line. So there's the first one. And I try to put as many points as I can across the grid. My next one has a y-intercept of 1. Slope is -2/3, which means down 2 and right 3. No more I can do over here, so I'm going to go up 2 and back 3. And that was super nice because now I can easily tell where they cross. And where they cross is the solution. And in this case, the x is -3 and the y is +3. Which means if you plug those in for x, -3 for x, and 3 for y, that will work out. Now, sometimes they're not in slope-intercept form and you don't want to graph it, and they're lined up so nicely like this that I tend to like to use the elimination method. You want something to fall out. One thing you can do in this one is if I multiply the top equation by 6 and the bottom equation by a -5, I notice that if I flip these numbers, and you don't always have to, there's other combinations of numbers that people choose. Sometimes there's an easier one, but for this one, looks like if we flip these numbers in front and make one negative, wait till you see what happens. If I do 6 times -5x, I get -30x. 6 times -2y is -12y. 6 times -2 is -12. If I multiply these by -5, I get 30x, 45y, and 45. Now, the reason I made one negative and one positive is that they currently had the same sign, and I wanted them to have different signs, because if I add straight down or combine right here, they go away. They zero out. And -12y plus 45y is 33y. Negative 12 plus 45 is 33. Divide by 33. Y is 1. Once I know one of either x or y, I can substitute into either equation. I tend to always go back to the first one or the original one. I'm going to replace the y with a 1. So negative 2 times 1 is negative 2. Now I'm solving for x, add 2. Negative 5x equals 0. Divide by negative 5, x is 0. So these two lines, or linear equations, if I would graph them, would cross at 0, 1. Now the last one, and you always have your choice of which method that you want here, but I want to show you all three, is solved by the substitution method. Substitution method means take one of the equations, if it's not already, and solve for one of the variables. Now, I would probably take the first one and solve for x, since x does not have a number in front of it and it's positive. So if I add y to both sides, x would equal negative 8 plus y. So negative 8 plus y. So then I go to the second equation and replace the x with negative 8 plus y. So it's 2 times negative 8 plus y, and the rest of it, negative 3y equals negative 22. So now I solve it because it's just one variable now. 2 times negative 8 is negative 16. 2 times y is 2y. Bring the rest down. Combine like terms, so I'd have negative 16 minus 1y equals negative 22. Then I'm going to add 16 to both sides. And when I do that, I will get negative y equals negative 6. Divide both sides by negative 1. Y equals 6. Now don't worry, we're not done. We got to make sure we plug it back in. That's why I like putting a box around whatever I solve one of the variables for, because that's the easiest one to substitute in for. If I plug a 6 in for y, x would equal negative 8 plus 6, so x equals negative 2. But again, I always like to write my final answer as an ordered pair where I write the x first and the y second.